Ready? Hi, Shannon.
Hi, Shannon.
We are recording for you today, but I didn't know you were going to be out. So when you know you're going to be out, let me know. That way I can record the class for you. And yesterday I wasn't prepared to do that. So I want to show you the notes we took yesterday. So everyone, we're just going to recap on the front. What were we talking about on the first front page there, Haley? Student. Student, what were we doing on that first chart? Do you recall?
We were doing conditional distribution.
Right, and we learned there were two sets of conditional distributions. So student who's recording, what you're being shown, Shannon, from this recording student is one set of conditional distributions. And what was that one? Could you, the first way that we did it, how did we word it, student 2?
Wait. What? Oh, no.
There are two ways to read each distribution. There are two sets for every chart. Okay.
We did conditional distribution of opinion among women.
Right. And then on the back, recording student, can you show her the back? Then we went the other set. And when you read this, Shannon, it'll make more sense. Go ahead.
The conditional distribution of gender among opinion.
Right. And we learned that when we word it that way, the one that we circle and we keep the same is the second one. So that's a quick rendition. And then what's that stuff at the bottom of your notes right here, student?
Oh, the mini tab?
The mini tab. Can you describe for Shannon what mini tab is? And that's right here, Shannon. What is that? Do you recall?
So the mini tab is, it takes the chart from up there, I guess.
Yeah, from the problem.
And gives all the percentages.
Right. And actually, if you look at the conditional distribution that we did on the front page and the second, all that information can be found in that chart. And that is a statistical software that we're learning to read. It's not something you will create, it will be given to you. And if you work in that field, mini tabs, you'll know how to make a mini tab. We will never make one. We'll just read them. So, all right, how much further did we go? Simpsons Paradox. Can you tell me, student, what Simpsons Paradox is?
Yes, it's an association or trend in a two-way table changes when a third characteristic is added.
Okay. And we were talking about what scenario, student? Yeah, what was the scene of the example that we used to study Simpsons Paradox?
Oh, this was the Titanic.
Right. And so what happened is when we did an association with the overall numbers, student, what did we find was the first way we did it, we found that what characteristic caused you to have least chance of survival on the Titanic?
If you were in third class?
Right. So first class had a much more survival rate than second and third. But then we added a third characteristic and it reversed some of that. So what was that third characteristic that we added, student?
It made the second class less than the third.
What was it? It wasn't that. It did make second class more dangerous than the third, but what was the characteristic we added, oh student?
Whether they were female or male.
Right. So when we added gender to that, some of the data reversed, and that's called Simpsons Paradox. Paradise. Okay, thank you. Now you're going to put it back. You're going to put it back on the board. All right, Shannon, we're being careful not to identify ourselves.
He just got
All right.
everyone over there.
All of you.
That's
why I was like.
All right, so this is only for Shannon, although it'll be up on YouTube. But anyway, I can send her a personal link.
So it is.
But anyway, we're going to talk about Simpsons Paradox just to finish it up. And that is, there is another example in the book. I'm not going to do numbers, but just the concept. and you read about it, and it had something to do with going to the hospital in a helicopter or going to the hospital in an ambulance. Do you remember reading that? So what was the problem? Where were they finding more deaths? In the helicopter or in the ambulance? Student 3?
In the helicopter.
Right. So that was like, it was quite a few more. But once we put in a third variable, it balanced out much, it made more sense. So it's like if the helicopter comes to take me to the hospital, I said, no, I want the ambulance. But the reason why so many die in the helicopter and percentage-wise compared to the ambulance can be explained by what third variable?
The severity of the accident.
Right, the severity of the accident. Very good. All right, so that ends our day 3 notes. That was a big day, that conditional stuff, so did good. I guess you did good. I'll know tonight, right? If you went the right way on your charts. Okay, day 4. And is there someone that can shine a light for Shannon on what the assignment was? For that, she was here, so I guess it was just last night's assignment. You have something?
This one?
Yeah. Can you show her that?
Yeah, I got it.
I
Okay.
have a sticky note, Shannon, with the information.
Are you gonna add that too? Can you put it on there too?
Yes.
Okay. All right, day 4
Wait,
is not going to be as complicated as day 3. So, all right, and when you're done showing her the assignment, you can show her this handout. You want to just take a handout for her? You have
Yeah,
like
that's
a
fine.
collection? Okay. All right. I'll go ahead and mention the homework for tonight, so when the bell rings, we don't have to scramble. You're going to read. I didn't put the read pages. Read page 27 to 34, and those 6 problems. There's about 2 of them that'll take some time. So 4 of them will be quick, but keep in mind to give yourself, to do that reading and to do the work, it'd probably take an hour, because that is like that. All right, so put that on your mental plan for tonight. All right, we are looking at some notes on day 4. We'll be studying dot plots first, and you already saw a dot plot this year up on the board when we did that drink test. We had a dot plot up here. So I'm going to just reintroduce that and go from there. Any questions on old material or stuff before I go on? All right. When we were doing the pie charts and the bar charts, did you realize it was all categorical data? Well, it was. So we're going to use, what's the other kind of data that is not categorical? Do you know?
Shoot.
Maddie? Whoever you are.
Oh no. It was categorical and quantitative.
all right, so we're going to use dot plots used for categorical, used for quantitative data.
Raindrop. Dot plot.
All right, so the quantitative data dot plot we'll take, if you would make a dot plot for me, I will, if you would put in the numbers 0, 1, 2, 3, and 4, that will be all our data that we're going to plot. So when I call out a number, like the first number is 3, I want you to go ahead and put a dot above the 3. Notice it's not right on the axis, and there's only one axis, the equivalent of an x-axis, and then, and so on. You saw a dot plot earlier with the water activity. All right, so I'm going to call out 16 data points. Can you plot them as I call them? Pardon? Yeah, start with the 3.
Wait.
Are you ready? No.
I have to make it lower because I'm.
Yeah, do
All
it.
right,
I'm gonna make it longer
fix
because
it,
people don't
fix
know.
it. I think the
How tall is it gonna
hardest
be?
it goes up, it looks like 6 dots. 16 points, and I think the tallest is 3. It has to go up 6. All right, ready? You already got the 3 that I called out. 0, 3, 3, 3, 2, 4, 1, 2, 3, 1, 0, 1, 2, 3, 2. All right. You have just done a dot plot for, and entitle it, it is the number of turnovers that the Oakland Raiders had in their games in 2009. So turnovers, Oakland Raiders, 2009. What's a turnover, Dan? Oops.
I'm already given away.
He's already identified.
A turnover is when one team has the ball and then they either fumble it and lose it and the other team gets it, or they throw an interception and the other team gets it.
Okay. So, not desirable. So we have now before you a dot plot of the number of turnovers in that year. So what I'm going to train you from that, well, first of all, what a dot plot is, which you kind of already knew, but I'm going to say a very vague word, but when I say it in stat class and when you see it on a test or AP test, it is very specific. It's looking for 4 things. The word is describe. Describe the dot plot. And when a statistician says describe, they mean 4 things always. We want shape, center, outliers, and spread. Shape, center, outliers, and spread. And we'll go through each of those for this dot plot. And we made an acronym of it with SOCS. S-O-C-S. So, SOCS. So we'll put this up to inspire you. Alright. So, SOCS. S-O-C-S. So, it doesn't have to be given in this order. The shape. Let's start with shape. When you're looking at the shape of your plot, recording student, could you hold your dot plot in front of the camera?
Yes, ma'am.
Thank you. Alright, I kind of put a quick rendition. It might not be real accurate, exactly accurate. Did I call out a 4? Okay. Alright, so shape, something like that should be before you. And when I ask you to describe the shape, what I want to know, first of all, is it symmetric? And so a symmetric shape would look like this. That would be symmetric. This one is not symmetric, because if I was going to draw an outline of it, it goes like that. That is not symmetric. So you're not going to use that word to describe this graph, but if a lot of graphs in this class will be symmetric, and you can call it that. For this one, it is called skewed. So the correct answer for this one is not symmetric, but I want you to write it down so you know that that is a possibility for shape. But the one that we are looking for on this graph is called skewed. And you have to tell the reader whether it's skewed left or right. And this happens to be a skewed left. You might have thought it looked like it was skewed right. In my gut reaction to it, I would call that skewed right, because the hump went over to the right, so it looks like it's skewed right to me, but that's not how it's defined. The way we can remember is if you want to ski safely, which way will you go? So draw a little skier at the top of the hill with his little poles. And he's smiling because he's going to come down safely. So if you're an average skier, which way do you want to go on this mountain?